In 610 notes, we're going to be starting to look at what we call some special right triangles. And the first one we're going to deal with are what we call 45, 45, 90 triangles. You'll also notice that these are isosceles right triangles, right? Isosceles means two sides are equal. And so let's first look at these three triangles and talk about how you would know that they were 45, 45, 90. So the first possibility is that in the problem, they may just give you this. Okay, and I hope the first thing you always instinctively do is find the other angle, right? And if you take 180, since the angles add up to 180, subtract the 90-degree angle on the 45, you'll notice this one's 45. That's why it's called 45, 45, 90. Okay. The other thing that might happen, they might mark these two angles equal. So, okay, if they're equal to each other, then automatically you know since it's in one triangle, if two angles are equal, the sides across from each other are equal. Okay, so again, that makes it so that it is a 45, 45, 90. And last but not least, they may actually just label the sides, right? If those are marked the same, then same thing in reverse. If the two sides are equal, then the two angles across from each other are equal. Okay, so in all of those scenarios, you'd have 45 degrees as both of the acute angles. Now, what you know about these that are marked the same, guys, we want to do this in general. So in general, if we don't know this length, I'll just call it x. And since this is equal, I'll call it x also. Okay? The one part you have to memorize is that if you want to get a hypotenuse, which is the longest side, you would multiply by a number. And if you ever want to go from a hypotenuse to a leg and get shorter, then it would make sense that you would divide by a number. The number here is root 2. So you would take the leg of x, multiply by root 2, and that's in general what you would memorize for a 45, 45, 90. So it's going to be x root 2. Now if you just want to put that in words, okay, then over here it's going to say to find the hypotenuse, right, you're going to multiply, right, because we want to get longer. So you're going to multiply the leg by root 2. All right, and then to find the leg, right, if you've got the hypotenuse, well, you want to get shorter, so you would divide the hypotenuse by that same number of root 2. Okay? All right, so let's practice with it. So first of all, let's just go through and identify straight across the first row, guys. Okay, and we'll do this slowly until you kind of catch on. So if I was going to ask you for the length of this side, okay, that I'm just marking, it's already marked in the picture. Well, it's supposed to match the other one, so that's 3. And now that I know that's a 45, 45, 90, right, because the two sides are equal, then I know the hypotenuse is that number times root 2. So 3 root 2. When you're doing a bunch of work in yours, you can just box your final answer, guys. I'm not going to box these so that they don't get complicated until I have more work in them. All right, so what makes the next picture of 45, 45, 90, or is it? And you should just be telling me these markings make it 45, 45, 90. So this length would be 6. This one would be 6 root 2. Okay. Next one, same thing. This would be 10 and 10 root 2 because of the equal legs. And then the last one here in this column, is this a 45, 45, 90? Well, if you do 180 minus the 45 and the 90, you would see that that is, which means you're supposed to know automatically that these two legs are equal. Okay, so this would be 8, and this would be 8 root 2. Okay. Why don't you turn it off and try the entire next row for yourself. But make sure that you are asking yourself if it's a 45, 45, 90 first. Right, let's see how you did. So the first one, it's these two angles being equal that tell you it's a 45, 45, 90. So you should have lengths of 12 and 12 root 2. It's these two marks that tell you it's a 45, 45, 90. So lengths of 20 and 20 root 2. Again, the 45 and the 45 gives you the 45, 45, 90. And one more time here, these two tell you it's a 45, 45, 90. Okay, so in those last two, you've got 100, 100 root 2, and then also 80 and 80 root 2. Okay? All right, now don't change the process. If you've got that down and you think you're fine with those first 8, don't change anything just because we put roots in the problem. Okay? It's still the same thing going on. So this one, right? That's what makes it 45, 45, 90. So the length of the bottom would be 2 root 3. And now how do I get the hypotenuse? I hope you're thinking that I'm supposed to take the leg, which is 2 root 3, and get longer by multiplying by root 2. So yeah, I'm going to see some work from you, and this is exactly, I'm modeling how you can show me your work. All right, good thing we learned how to do this stuff. Remember, these aren't word problems, so these are no decimals. We're back to our roots. So you're going to tell me 2 root 6. Square root of 6 does not break down any further, so that's actually the answer. You can just box it. Ready? All right, the next one is 45, 45, 90, if you find that. So the bottom length is 6 root 6. Hypotenuse, to get longer, I need to multiply 6 root 6 by square root of 2. All right, so that gives me 6 square root of 12. Square root of 12 does break down further. Okay, however you want to do that for yourself, either the perfect square or factor tree, like it's 3 times 4, and 4 is root 2 and root 2. Okay, so hopefully you can visualize that now enough to see that a 2 is going to come out times the 6 that was sitting in the front, and the root 3 is going to be left over. So 2 times 6 is going to be 12 root 3. Do more work if it's going to help you to get that correct. Okay? Again, these marks make it isosceles, and 45, 45, 90, since there's a 90. So this would be 3 root 5. Hypotenuse would be 3 root 5 times root 2, 3 root 10. 10 does not break down any more than 5 and 2, so I'm finished. And the last one, these two marks at the right angle are what make that a 45, 45, 90. So the bottom would be root 10. The hypotenuse, you would take the root 10 times root 2, which would equal root 20. Ooh, definitely need to break that down. Maybe I'll do this one with perfect squares. 20 is 4 and 5, so root 4 and root 5, since 4 is a perfect square. And therefore the square root of 4 is 2. So I'm going to get 2 root 5. All right, there we go. Now, working backwards to find the legs if I have the hypotenuse. Okay. This is what you need to have memorized. Okay, is this thing in general. So if you've got a 45, 45, 90, these two are x. Remember the hypotenuse is x root 2. Okay, so the more you can write that to get that kind of pattern down, the better you are. So notice, guys, if the hypotenuse has a root 2, right, then right there, if the hypotenuse has a root 2, then isn't x that you get just sitting right there? And that's what these become. So if you recognize that it's the root 2, and it's exactly what you're starting with, then it should be pretty straightforward going backwards. Okay, forward, backwards, I saw it. All right, anyway, since this has a root 2 right there, I know that if I just get rid of the root, that this would be 7. Okay, both of those would be 7. Now, what if you're not looking at it that way and you want to do exactly what this said? Well, here, we'll convince you. 7 root 2, we're supposed to divide to get shorter by root 2. Okay, well, when I do that, don't these cancel? And you just get 7. Okay, so that's exactly what I'm doing, but I'm also was trying to do that by noticing the pattern. Okay, so on the next one, I notice that it is a 45, 45, 90 because of this. So both legs will be equal. And if I have 41 root 2 for the hypotenuse, then each leg would be 41, because dividing by root 2 would just cancel those. Okay. That next one, again, there's why it's 45, 45, 90. Since it's root 2, each of these would be 5. Next, if you put the 45 in here, that's 45, 45, 90. Uh-oh, it's not a root 2 anymore. So I can't just, bam, plaster down like a 10, because that would be wrong. Okay? So if you need to, you are either going to be more of an algebra person and go ahead and say that this equals x root 2 from our sample problem above, and then just ask yourself how to solve for x, which I hope you would say divide by root 2, or you're just going to have it memorized. Okay? So if you're trying to find the length of the leg, show me your work here. You're telling me take the hypotenuse, divide by root 2 because you either did the algebra from above or you just memorized the pattern. And then please don't forget, guys, the tricks of square roots. Okay? This is the same as, since the 6 and the 2 are both under square root, you can just think of it as 10 times the square root of 6 divided by 2. So if that 6 and 2 reduce to something easy, you can jump straight to 10 root 3. Okay? If it doesn't reduce, you have to do something called rationalizing that you did in your previous algebra class. And we'll get there. We'll end up talking about it anyway. Okay, but that's just the way I'm going to approach that one. Okay? All right, so then if I ask you for the other leg, then of course that one's going to be 10 root 3 also. Okay? All right. Again, don't get rid of the pattern just because we're changing the kind of numbers. So, next one. If we put a 45 here, you got your 45, 45, 90. We're supposed to take the hypotenuse to get this leg, and we're supposed to divide by root 2. Okay, there's no roots to reduce like we did on that last one. So rationalizing, guys, because remember you can't leave square roots in a denominator. And remember the trick was you're just multiplying by that same thing on the top and the bottom. Because root 2 over root 2 is 1. You can't just randomly change a problem, right? But I can multiply by 1. That doesn't change a problem. Remember for fractions, you multiply straight across. So 14 times root 2 is 14 root 2. And in the denominator, root 2 times root 2 is 2. Okay, completely reduce. The 14 halves, the root 2's don't have anybody to reduce with, so the 14 halves is 7. So this side is 7 root 2. Which means this side is also 7 root 2. Right? Next one. Here's the reason it's 45, 45, 90. If you take the 12 and you divide by root 2, we have to rationalize by root 2 over root 2, because that's really 1. Multiply straight across, we would get 12 root 2 over 2, and finally reduce to get 6 root 2. This leg would also be 6 root 2. Okay. Now notice, those of you that are pattern people, you might like this shortcut. Notice the pattern. If it's 14, notice what I got. Versus if it was 12, notice what I got. And really think about the number without the root for a minute. So 14 gave me 7, 12 gave me 6, So it's half and then multiplied by root 2. Well, will that always work that way? Well, those two are nice because those were even numbers. Okay? Let's see what we think if that pattern holds true when we have an odd number. Okay, so I'm just going to say here, notice your shortcut. All right, so in this one, we're going to say, here's the 45, 45, 90 reason. Take 15 and divide by root 2. Rationalize. So we'll get 15 root 2 over 2. And notice 15 halves does not reduce this time, guys. This is your answer. Do not ever give me a decimal with a root. So 15 root 2, this is exactly how you write it, over 2. That is your final answer. Let's check out our shortcut. Did it work? Should I be able to take this and cut it in half? Well, 15 in half is 15 halves, and multiply it by root 2. Yeah, if you start recognizing that pattern, guys, go for it. Okay? We want to get you as fast at these as possible. Last one. Here's the reason it's a 45, 45, 90. We need to take the hypotenuse and divide by root 2. Rationalize by multiplying by root 2 over root 2. And we will get 4 root 6 over 2. And the 4 halves reduces to 2. So 2 root 6 would be our answer for that leg. And this leg as well would be 2 root 6. So now, in order of preference, we first check to see if we have a special right triangle called a 45, 45, 90. After that, we do reducing. After that, we do triples. And last but not least, Pythagorean theorem. But let Pythagorean theorem be your last resort as of now.